Let's dive into it. Jeff really did all the hard work here, and I'm just along for the ride and excited to add in my commentary. But Jeff has really been working on this for probably a good few weeks late last year, trying to come up with a very systematic way to compare Snowflake and Databricks from a cost and performance standpoint against what we felt was a representative set of workloads. But we'll obviously share what exactly is representative set of workloads, doing your own testing, et cetera. But really excited to share the results with you. And we're going to walk you through all that today. So, Jeff, do you want to pull up our slides and we can just get rolling here right away?
This was a really fun project to work on. We did want to make it repeatable for everyone. So there's going to be a public GitHub repo.
To get set a quick agenda, as Jeff mentioned, we really focused on coming up with a repeatable experiment. So, we're going to start by really talking about first a very quick overview of like why we're doing this just to set the stage, but then talk a lot about like how we actually went and set up these representative data sets and the different scenarios we ran. And then we'll really spend the bulk of the time on 3 and 4, what you're all interested in learning about, which was just tell me which one's faster, tell me which one's cheaper, tell me which one's better. And we'll talk about how you can really interpret these results and how you should consider them if you are doing a platform evaluation. I want to start with the why behind this because I do think it's really important to just set the context for this. I'm guessing most of the people who are here are probably not numb to the fact that there's a lot of very contentious or healthy, potentially contentious debate around Snowflake and Databricks. These are really two incredible companies, both of them. They're both growing like crazy. They both offer, I would say, a world-class experience for a modern data cloud platform. And naturally, they're fierce competitors because they're going after the same market. And both of them, being great products, have very passionate fan bases who will debate things on LinkedIn. And it's very fun to watch. And I think the thing you have to be careful of is a lot of the times when you're watching these two sides speak about their respective platforms, there is a natural bias because of usually it's people who work at these platforms or are people who are very passionate about those respective products. So one of the reasons we wanted to do this was to stand aside as a independent third party. So for some background for those who don't know about us, so my name's Ian. I'm one of the co-founders and CEO of a company called Select. We are a data cloud cost management platform that has historically been focused on Snowflake, but we also have a Databricks product that is currently in private preview. So we have familiarity with both products, although I will put it out there that I have a historical, more natural familiarity to Snowflake. So I will just share that up front. And I think the same is true for Jeff. So for those who don't know, Jeff is the founder of GM Data, an independent consultant focused solely on Snowflake. And what today's talk is going to be on is really focusing on Databricks SQL Warehouses product along with Snowflake's SQL Warehouses product. So both of these platforms, say the word data cloud and not data warehouse because they're more than a data warehouse. However, a predominant workload that companies use on both platforms, traditional data warehousing workload, which runs on SQL warehouses. So that's what today's focused on. So it's even like a sliver of, I'd say a large sliver of functionality on those things. So we wanted to come up with that benchmark that, again, is from our perspective, a third party that, is arguably less biased than someone who works at Snowflake or someone who works at Databricks. I will caveat that like we are a Snowflake partner and we hope to become a Databricks partner as well. So I just want to put all that out there in case someone comes up after and says, oh, you have this bias, trying not to, but we do work closely with Snowflake in our day to day. The last thing that Jeff will talk about is this really is meant to be a completely transparent and extensible set of benchmarks. So the repository we used for this is fully open source. It's designed for anyone to be able to, with Python, run a job and reproduce these results themselves. There is a setup that's required, which Jeff will talk about, that is you need to like load data into these two systems so that you can run these experiments, which is a little annoying. But once you have that, it's very easy to run these experiments. And honestly, the last reason for doing this is just a lot of fun. Like Jeff and I are both performance and database nerds, and it's always fun to just see, hey, where does this one platform do better, do worse, and vice versa. Agree. You had to put this up, Jeff.
Thanks, Jeanette.
Yeah, Jeff. Jeff is great to work with. He also has a fantastic t-shirt. I don't know, Jeff, if you want to show the t-shirt, which is like
Yeah.
perfect for today's webinar. The number doesn't quite look right. I'm sure we'll get a lot of that once we start putting up some numbers.
If anyone
All right.
doesn't like the numbers, I'm already wearing the shirt to just say yeah.
So I think one of the most important caveats that we will probably repeat more than once is that benchmarks only tell you one thing, which is how fast the benchmark ran. So that is maybe slightly nuanced, but just to really try and hammer that point home, like we're going to put up charts that show Snowflake was faster here and Databricks was more expensive, or Databricks was faster and cheaper here. And what I want to be clear is like all that tells us is for that particular benchmark, for that particular workload we ran, Databricks may have been cheaper. Or for this other workload that we ran, Snowflake may have been cheaper. And at the end of the day, all that all you can do is take that for what it is, which is it's faster for this very specific workload that was ran. Our attempt was to create something that is as representative and extensible as possible to what other companies may have. But at the end of the day, if you're in a position where you're making a decision on a platform, you should obviously do this yourself. You may use our work here as some motivation for how you would do that benchmarking to do how you come up with a very representative set of workloads in your environment and how you would actually measure cost and performance. I think all of that you can definitely take from our framework. But at the end of the day, you need to test it on your stuff. And there's also a bunch of other factors outside of just pure cost and for performance that you also need to consider, which we'll talk about later. So that's one caveat I want to leave you with. And with that, I will shut up and turn it over to Jeff to really quickly run you through the data set, the repository, and then we'll jump into the results.
Cool. Thanks, Ian. So yeah, let's get into the data set that we use. So we're using the TCPH 1000 data set. So that's scale factor 1000. This comes with 6 billion rows, at least in Snowflake it does. No special sorting or clustering was done to the data. We just took it as is and unloaded it and loaded it into Databricks as is. So it's kind of interesting. There's no common benchmark data set between the two platforms. They both come with sample data. They both come with TCPH. They both come with TPCDS. They don't both come with the same sizes. And boy, it does feel on purpose, but I really wish that Snowflake and Databricks could just have the same data set so we can easily do this. And then we don't get complaints that, hey, the data set wasn't optimized in warehouse 1 or warehouse 2 or whatever. But yeah, so we had to ETL the data set. If you're going to do this yourself, I highly recommend using an ETL platform to do this and not trying to do it yourself, because loading the data into Databricks was a little bit of a pain, unless you're just a Databricks expert or an expert in both platforms. But I was able to unload the data from Snowflake to a stage using just an AI prompt that says, hey, you have access to my Snowflake CLI. Just go ahead and unload this data. And then I was like, okay, now load it into Databricks. And then boom, 24 hours later, I was finally there because I had to actually learn how to do it myself because the AI choked on it. But yeah, so if you're going to do it yourself, probably just use a tool. You'll save yourself at least a day. Or if you already know how to do it, then you're all set. But we tested 5 scenarios. The goal of this entire project is to give a representative set of real world use cases. So we came up with 5 scenarios. There are 22 standard benchmark queries that already pre-existed. It comes with the TCPH documentation, and there's a little repository that it links out to that has, hey, here's our standard queries, and they are all select queries. And they're all very highly aggregated queries. Some of them have a lot of joins, some of them are very complex, others are simple. We'll look into the profile of some of those queries in a little bit. I'm going to save the explanation of the 5 scenarios for when we go through them, so that way I explain them fresh as we're looking at the scenarios. But you could see sequential queries, concurrent queries, cold start, so no warehouse cache, create table as select in different shapes, and then DML, delete plus insert, is the DML scenario.
And just to chime in quickly here, for anyone who's just joining us, to clarify, we are solely looking at pure SQL workloads here. So for those coming from the Databricks side, we're not talking about Spark jobs or Lakebase, the new Postgres-based transaction. Like both Snowflake and Databricks now have a Postgres offering and can do data science workloads, and both actually have a way of running Spark workloads. Like we're not testing any of that here. We'll probably update the slides after to say 5 scenarios tested for SQL warehousing.
Yeah.
And then, yeah, as Jeff mentioned, if you think about what does like every company do out there, they load data into their warehouse, they transform it, doing transformations in the warehouse. CTAS and DML are the common patterns there. And then there's a whole bunch of where does all the value in data come from, actually running queries
Right.
against that to answer
Yeah.
business questions. So that's what those kind of first three are, these like sequential queries, concurrent, and that's starting to get into a bit of the nuance around scaling and cold starts, et cetera. So that's just a quick context and summary behind those.
Perfect. So understanding warehouse size comparisons, this is pretty tricky here, actually. So a Databricks warehouse is roughly equivalent to a Snowflake warehouse that is one size larger. And we have some evidence of this linked to the documentation, but basically we believe through our research that a Snowflake medium is equal to a Databricks small, and a Snowflake large is equal to a Databricks medium, etc. And these are the three sizes that we tested, and therefore the three sizes that we compared.
Jeff, just so we can show people, I think it's interesting. Do you want to just click the link and we'll explain why? So really where that's coming from is this worker count, right? So it's common knowledge. I don't know if it's published in Snowflake's docs, but it is common knowledge that if you're using an extra small warehouse in Snowflake that has one node or one worker. So that's why we've come to this realization. And this was also provided to us by a few other people who are deeply familiar with both platforms, that when you're talking about a extra small warehouse in Databricks, it actually has double the computing power, right? Because there's double the workers as a Snowflake extra small warehouse, right? This all gets normalized out when you're comparing costs. It doesn't matter. Like if we compare an extra small Snowflake with a small Databricks or a small and a small, like from a cost standpoint, cost is cost. We factor in what they price. But I think it's really important from a performance standpoint, where if someone goes and makes a claim saying this is faster, you have to look at both that price and performance. What is all the compute behind that? And is that apples to apples? So that's really why when Jeff did this, to start, we would compare, if we were looking at query performance, we would want to say, okay, let's give these equal amount of compute and then compare, and then let's also compare the costs. And I think, Jeff, correct me if I'm wrong, in the results comparison, you can do medium small or just small, small as well. Like you can see those in the app.
Plotted on the charts, the comparisons are done at this level.
Okay.
No, but we really benchmark at the lowest one that we are counting in the results is the Snowflake medium, but we also drew on the chart the Snowflake small so you can visually see it and see how it did.
Yeah.
So cost attribution. So we wanted the cost attribution to be as perfect as possible. So we wanted to programmatically create a unique warehouse for each run. A run could be multiple scenarios, as we listed on those 5 scenarios. And one run could actually be multiple warehouse sizes. So it might programmatically create one of each size depending on your run configuration. But we didn't want to use an existing warehouse where then we would have to do some weird cost attribution per query and say, okay, there was overlap between this warehouse doing other work and the warehouse doing the benchmark work. So we didn't want any of that stuff. We wanted how much did this run cost, and we wanted cold hard facts about it. So the only way to do that is to create the warehouse, do the run, destroy the warehouse, which is what we did, and then get the actual billing data for the run.
Yeah. Very helpful call out for those who are new to either of these platforms. So both Snowflake and Databricks bill you based on warehouse uptime. So even though what we're talking about here is queries, right? We want to run queries, the actual unit of work, and compare them. The billing is done at a higher level. It's done at the warehouse level. So in order to have no kind of open questions around, oh, how did you attribute cost to the queries within the warehouses? We took this very conservative and accurate approach of just create a new warehouse programmatically every time we want to run one of these benchmarks, so that we have a very clear, this is what it cost, period.
We ended up
No,
creating
no
and
debate.
destroying dozens of warehouses, if not hundreds of warehouses.
Jeff blew up our bill in the process of doing this. So I hope you all, I'm kidding. I don't think it was that bad.
I want to jump into the pricing comparisons. So we thought the fairest thing to do was take the entry level price for each one of the platforms and say, we're going to compare the lowest price that you can legitimately pay for. And in Snowflake, that is standard at $2 per credit. Databricks has gotten rid of their standard in most regions and most cloud providers and only have enterprise now. That's 70 cents per Databricks unit. The reason why they sunset their standard edition is because there was no role-based access control. It was basically everyone had access to everything, and who really actually use something that doesn't have any role-based access control. The first legitimate entry into Databricks was the enterprise tier anyway. So they got rid of their standard tier in most regions, as I said. So we thought it was fair to compare the standard versus enterprise. But for all of the people who are going to throw tomatoes at us for doing that, we have also included in the results enterprise versus enterprise. And you're going to see the pricing for both on this webinar today for all of those scenarios.
I wish I brought a tomato I could throw at you. That sounds fantastic.
I'm gonna keep this really short, but I do want to just show you that the documentation in the repo is really good. It covers everything we just talked about, including the getting started. We're using UV, which is a new age Python package manager. So if you're a Python person, you've seen this already, but you just run UV sync.
So hot right now. It's
So hot right
It's
now.
written in that metal related language, Rust. Yeah.
You run setup config, which is really cool. If you don't have Snowflake CLI and Databricks CLI installed, it'll install it for you. It'll walk you through the configuration of your credentials connecting to your Snowflake account. So you just run this one command. It walks you through setting up the whole project, including generating a .env file for you automatically. And then to actually use it, I'll just scroll way down. There's just a bunch of commands that you can run. So if you want to just run the whole thing wide open, which will run all the warehouses, all the scenarios in sequential order, you just run it wide open. But if you want to do something fancy, and I have one teed up just so you can see like how cool it is, you could actually do this and it's kicking off. Okay, I spun up a medium warehouse. I'm going to run these particular queries that I said, and then it goes ahead and it kicks off those queries. This is a concurrent run. It's
hammered the warehouse with 3 queries at the exact same time.
At the same time. And the cool thing is you can actually kill it. I think since it's doing concurrent, it'll take a little bit longer to kill. If it was so, even if you kill it, so I did Control-C to interrupt, it does destroy that warehouse, so it doesn't sit there and linger. So it's like that try except finally thing that Pythonistas are familiar with. So it finally will kill the warehouse no matter what happens. So anyway, let's jump into the results, guys. What everyone came here for. Let's go back into slideshow mode just to see here. Scenario 1 is the 22 sequential queries. And what is the goal? Like, why did we consider this as something? So this mimics what you may experience when you're sitting at your desk actually running queries. Now, when you're doing ETL or you're doing dashboards, that's usually concurrent queries. You don't normally have a dashboard that just does one query at a time or an ETL. But this is if you're working and you're just sitting there working, it's like, how fast is it going to take to run one query? What about 22 times over, different queries, etc. The setup is exactly what we talked about. Create the warehouse, run the 22 queries one at a time, destroy the warehouse. And then we log all the results to DuckDB. So I can see every run that I've ever done. It's just in a DuckDB. So in the repo is instructions for launching this very cool web app brought to you by Claude Code. And here now you're seeing the results for the 22 sequential queries. So drum roll, please. At the grand total level of running 22 sequential queries, Snowflake is 34% faster and 17% cheaper, doing those comparisons that we said, which was medium to small, large to medium, and extra large to large. So if I want to actually highlight the comparisons for you, we have some highlighting going on here, where now we can see that at this lowest comparison, normalized comparison tier, which is medium versus small, see the results here that Snowflake was 30% faster, but Databricks still came in 25% cheaper. Here on the large versus medium, Snowflake just blew it out of the water. Head and shoulders above on both metrics. And here also head and shoulders above on both metrics. When I remove the highlighting and the filtering, it doesn't count this small all by itself like we talked about before, because that's just in case anyone wanted to say, what is a small versus small? Yeah, Snowflake is slower. It happens to be cheaper because it's a small warehouse. And there's the extra large by itself for Databricks, but the comparisons are only done at these levels. So it looks like just for a select query running one at a time, no multi-processing, no concurrent workload hitting the database, that in this scenario, with these particular queries, Snowflake is both faster and cheaper.
And Jeff, do you want to just show if someone wanted to plug in their actual cost per credit to say,
yeah.
Like, actually, what I've been quoted by so-and-so.
So I promised I would show them at both $3 a credit. So that's a good time to actually do it. So at $3 a credit, Databricks is 20% cheaper. And you could put in your cost per credit here. Like most people end up paying, I see 283 show up a lot. after you negotiate with your sales rep and get a discount. I see this number show up a lot. So this is like what you might actually be paying for standard for enterprise edition. And then you could put in your Databricks math there. But the
Yeah.
list
So,
prices are
oh,
three
go
in
ahead.
sales.
Yeah. I'm going to ask a great question from Andy here. So, Andy asked, does the Databricks costs include Databricks and the cloud provider costs? So, for some background, for a bunch of Databricks services, especially when you're spinning up Spark clusters, they will actually go and spin up cloud resource or compute resources in your cloud, i.e., in your AWS account. And then you're actually dinged with two parts of your bill. You have the Databricks costs, and then you have your underlying cloud costs. So that's the background on why Andy's asking this question. Now, I shared this earlier in the presentation. We are comparing Databricks serverless SQL offering to Snowflake's. They just call it their virtual warehouses, but it's also, for all intents and purposes, it's also serverless. So both of these products, the only cost you pay is what the cloud provider charges you. So it's just DBUs on Databricks, it's just credits on Snowflake. So I think that answers both of these questions. I think Brian had a similar one. So
Yeah.
you're right, Brian, again, but for Databricks SQL warehouses, the only cost you actually pay is the DBUs. So this whole presentation is focused on Databricks SQL warehouses. And we're not trying to, this actually could be an interesting follow-up of add in run the same workload in Spark, for example, although that would really only apply for some of the ETL stuff, and it wouldn't apply for these live, or it wouldn't apply as much, I think, for these live queries, because it's just not the use case for them for Spark.
Cool. Just to point out before we move on and cover the next scenario, you can click this view query details where you could see all of the queries that ran and the comparisons and stuff like that. And so we're not going to go to this level today, but if you're running this app for yourself, you are more than welcome to go into that level. Cool. So let's go back into slideshow mode and let's talk about scenario 2. So scenario 2 is the 22 concurrent queries. And the purpose here is to mimic what a BI dashboard would do when it loads. So every tile on the dashboard, every filter, every drop down on the dashboard is sending a SQL query to that database, and it's sending it all at once, isn't it? So concurrency is really important. This also happens in ETL. If you follow our advice, Ian and I will preach to set 16 threads on dbt, for example. I just noticed, okay, no, we're good. I thought I was muted for a second. So yeah, so this is ETL, this is BI, and the setup is exactly the same, except now Python is blasting all 22 queries at once. Okay, so let's actually show the results. Scroll down a little bit. We're still at $2 a credit, 70 cents per DBU. Snowflake is winning on these scenarios. And I do believe in this cut, yeah, Snowflake won all of the scenarios. And if you look at the numbers, are actually pretty large here, and the large and the medium. We have a lot more to say about this when I have some follow-up slides, but before I get into talking more about concurrency, Ian, anything to like chime in here?
Yeah, I think so. Rajiv asked this question a while ago, right? Which I think this before we presented any results, he popped this up, but I will present this question as if it was asked on the slide. And I think this applies generally, right? Like, why may there be differences in performance between Snowflake and Databricks? There's actually a variety of reasons. So I think first and foremost, there's fundamentally two different query execution engines, right? So Databricks, someone can actually chime in who probably knows Databricks better, but from what I've understood, they have started with Spark as their framework, and I think heavily added things onto it, heavily modified on it. They may even be using a custom version of Spark or their Photon acceleration for SQL serverless warehouses. And then on the flip side, Snowflake has their own proprietary in-house. It actually doesn't even matter what Databricks is using. The point is they are two different SQL engines. So each SQL engine makes its own assumption about how should we execute this query. Number one, the query plan. And number two, they just have everything implemented in a different way for how they process data. So that will be a huge factor. Number two, they may have different hardware decisions, right? Under the hood, I think Databricks on their website showed they use, like on AWS at least, it was like an i3 X large instance. Snowflake does not disclose what instances they choose. They may have chosen the same one, they may have chosen a different one. So there's just a whole bunch of factors because they're just fundamentally two different engines that are executing things. That applies to everything on all these slides. What Jeff is showing here with respect to concurrent queries, right? So if we think about what's going on when you have concurrency in either of these platforms, there's factors that come in like how well does the autoscalers work for each of these two sets of virtual warehouses. So Jeff shared this earlier. Snowflake and Databricks allow you to choose two kind of key parameters. There's more, but two of the key parameters are the size, which we've shown on here, and what's called the cluster count, which is how many copies of the warehouse can Databricks or Snowflake create in order to serve this big influx of queries. So another factor playing into this specific experiment is how well does Snowflake scale up to serve those queries, and correspondingly how effectively does it scale down to keep cost effective. So those are actually two different things being measured here.
Yeah. And that's actually a good lead into the further explanation on scenario 2. We'll talk about concurrency for a second. Programming 101, if you've ever learned about calling something asynchronously or using multi-processing, etc. Imagine a function in Python that just sleeps for 1 second. And if you call that 5 times in a row, it's going to sleep for 5 seconds. If you call it 5 times concurrently, the whole thing is going to take 1 second. And that would be perfect concurrency, because there's no resource contention where, oh, I'm overwhelmed by processing, so it's slowing down the 5 threads. So in the perfect scenario, if the concurrency was perfectly, running the 22 queries concurrently would only take as long as the single longest running query in the first experiment. But we know that's not how databases work. If you throw 22 queries at once, it has to think a little bit about this one and think a little bit about that one. So you get this slowdown effect. And so I just did a ratio of what was the longest running isolated query versus the concurrent wall clock time. And Snowflake comes out a little bit ahead. It's not completely conclusive, but I mean, it does come out ahead. And then on this next slide, I want to mention here that when running on a medium or a large warehouse, this is the clustered number. I didn't show the SQL here, but it's in the blog post, the actual SQL used here. It utilized all 4 clusters that I gave it. So I said, you're allowed to scale up to 4 if you want to. If you think it'll help, scale up to 4. And for these 2 warehouses, it did. And on the extra large, it was like, nah, I don't need that 4th one. And it scaled up to 3. And this data is not available for Databricks. I've done a lot of research to try and figure out how many clusters which cluster number it ran on, et cetera. And it doesn't.
Oh, really? They don't expose that in the
I don't think they expose it as far as I can tell. I'm not a Databricks expert, but
yeah. Okay. Awesome. If someone from Databricks wants to chime in and be like, hey, here's where you get the cluster number, we can definitely go back and have a look at that. But yeah, so very cool. I hadn't seen the ratio. That's an interesting way of analyzing it. So super cool. And obviously important, right? If you have those live workloads, that's part of how you're planning to use one of these 2 platforms. I think that's an important thing to consider. The other thing I'd call out is like Databricks is much earlier on in their journey with SQL warehouses, right? Databricks started as a Spark ETL data science, data engineering heavy platform. It was less focused on like these BI type workloads. And kudos to them. They've come out with a incredible SQL warehousing product in a very short period of time. So just keep in mind everything we talk about here, like Databricks is constantly improving their product. So it's quite possible, like maybe today they're slightly worse at this concurrent. Well, for the specific benchmark we ran, to be clear, possibly on other queries, they're better. But for the specific benchmark today, Snowflake outperformed Databricks on the concurrent queries. Maybe a year from now, that's no longer the case because they make changes to their auto scaler or whatever.
Yeah. Maybe after this webinar, they're going to get started working on scaling faster.
Yeah. Who knows?
So the next one was cold start. So just a very simple background on Databricks and Snowflake actually work pretty similarly here, that if you run the exact same query twice, it'll read the results from like a results cache. So for all these experiments, we had results cache turned off. I think it's called something different in Databricks, but concept applies. But then there's this other type of cache called the warehouse cache, which when it reads the data which exists in Snowflake's remote storage and pulls it into that VM, which is computing your data, it will leave a copy on the hard drive, not the actual query result, but the data it needed to fetch from remote storage. And as long as that warehouse stays on and stays warm, it has that copy of the data physically there on the VM, so it doesn't need to fetch it again. And so we wanted to say, so if you run 22 queries, like sequentially, query number 2 benefits from the warehouse cache of query 1. And every query actually is now considered like a warm query. It's all benefiting from the warehouse cache from the queries that came before it. So we wanted to see if you cold start, you turn the thing off between every query and then run it. How does that shake out? It's called photon acceleration in Databricks, Warehouse Cache, and Snowflake. This is a very expensive endeavor because every time you resume a warehouse, Snowflake will charge you for 1 minute. And we didn't want extra large 1 minute being charged for every single time I was running this experiment, building, developing, etc. So we just chose 5 challenging queries for it to chew through here.
Yeah. And two things I'll call out here. I think on that note of Databricks constantly improving, I know for a fact, they are a bit slower in terms of warehouse startup time, right? So you think about what happens when you run a query against either Snowflake or Databricks with these virtual warehouses. Behind the scenes, they have a giant pool of VMs sitting there. When you say, I want to run a query against a extra small warehouse, they go grab the resources necessary for that. They spin up that warehouse and start running your query. Same thing in both platforms. As of today, Snowflake is just for a fact much faster at that. Again, purely because this is the product they've been investing in and fine tuning for their whole company lifetime, whereas Databricks is newer on that. I do think Databricks publishes some benchmark. I'm not sure if it's warehouse startup time, but what I just know anecdotally from being in the space is that they've been dropping that year over year because it is such an important thing. When someone loads a dashboard, they want it to just load like that and not have to spend all this time for a warehouse to resume. That's another important aspect I want to talk about is there's this warehouse startup time. And then there's also the cache separately, which can play a factor in your query performance. Very important for BI based workloads. I think there's a good, very relevant question from Powell here about, Jeff, do the results of your benchmark contain the time required to spin up the warehouse and the overhead of warming it up? For example, so are you using that like query total elapsed time or the execution time?
Yeah, I knew this in December. I don't remember if it's including the spin up time. The cost is the cost because that just comes from the
Yeah.
data, so it doesn't matter. The elapsed time, I forget if it includes the startup time, but it was on average, I did measure, it's about like 6 seconds on Databricks to do the startup.
I kind of go ask Claude and have it look at the repo and see what column it used and see if we can get the answer from that.
It's not, yeah, it's not necessarily the column, it's when the starter, because I'm using like a custom thing called wall clock time. So it's when the timer actually.
So there's the answer, right? If you use wall clock time, then it would include.
But does wall clock time start before or after the warehouse? I think it's before.
Yeah.
The warehouse creation.
We'll confirm this, but to answer the question with 80% degree of accuracy, and you can sue Jeff, not me, if this is for me, that it's measuring that end-to-end wall clock time. And the reason for that is that we want to simulate what a user experience. And the user doesn't care if there's this startup time. Like they experience what they experience in front of them on their screen. How long does this thing take to load?
Yeah. Same person, Powell, said that they love the work that we've done and they've experienced similar results so far. Pretty
nice.
Cool. So cold start. Last thing to say before we show the results on cold start is just the queries that we chose and the complexity. So we have basically like a 3-table join, a 6-table join, a 4-table join, an in subquery, also with a halving. So these are like the different complexities, low, medium, and high. So just a little bit of information there. So we will go to the results, which is going to be here. So starting with $2 a credit, 5 cold start queries. Snowflake was 54% faster and Databricks was 25% cheaper. And this could actually be, I wonder. Oh no, all of these queries were longer than a minute. Yeah. Okay.
Yeah,
I was wondering for a second. Yeah. I was. And then looking individually here, crazy to me. Somehow Snowflake was 40% faster, yet still more expensive. So these are how it shook out.
You are looking at what happens if you adjust to like the standard price per credit on $2.
Oh yeah, 2. Okay. Then Snowflake is cheaper across the board on the $2.
Yeah. So I think this is a really important thing to call out as well as you go through these results is like they're super sensitive to what is your cost per credit or your cost per DBU. Like what's the normalized price you're paying for the thing? And unfortunately, that's what makes these cross-platform benchmarks really difficult to do. They don't have this like standardized currency they charge in. They charge in their own virtual currency of credits on Snowflake or DVUs on Databricks. And each of those then have an associated dollar cost, which can vary based on how important of a customer are you? How much are you committed to spending on the platform? How much does your account executive like you?
Yeah.
I'm just
The
kidding. They're more rigorous than that and less subjective, but it's such a huge factor that it's just something you need to be careful of and conscious when anytime you see any benchmark, right? You gotta factor that in.
It's so true, and it's with all cloud services. If you try and figure out, is Google Cloud Run cheaper than Amazon Elastic Container Services? Good luck, really, because like they just bill for different things, and the pricing units are so different, and cloud providers are really good at making it hard to do these comparisons.
Yeah, for sure. Cool.
Let's just cruise through to the next scenario. We're getting to an interesting twist in the plot here. Okay. Create table as select. So this is a common thing that people will do when they're loading data, usually for the first time. And then after that, they'll do incremental updates. Unless it's a small table, you might just do this every single time you run your ETL job. But this is an ETL pattern, an ETL mechanism for creating a table from data that already exists or replacing a table. Now, here we needed to use different queries because the benchmark queries, those 22 standard queries, even though they scan large data sets, they return small data sets. So the writing of the data was like negligible, and it was almost the exact same amount of time as just selecting the data. So we needed to come up with some different CTAS queries, which would write a lot of data in order for this to be meaningful at all. So there's different complexities that we did. So we did narrow tall, which is like just the primary and foreign keys from one table. It's 6 billion rows, 4 columns. So that's a very narrow table. Then we did 16 columns, a partial data set, and then one where we joined all of the tables. There's 8 tables. So there's 8 tables included in this data set. We denormalize, aka join them all together, and write out all 59 columns. And how long does that take? And this number 5 is an outlier. So when I show you the results, I can show you with the outlier included, because this takes hours and the rest of these take minutes. And then I'm going to show you without the outlier included. Okay, so scenario 4 results. So this is with the outlier included, that one query on a medium, it was taking Snowflake this many hours. And compared to so it was like 4.3 hours. Databricks ran that same query on the equivalent warehouse size in 1.9 hours. So in just this small versus medium scenario, we'll look at others because it's really interesting, actually. Databricks is twice as fast at writing this table from scratch than Snowflake is. We know that Snowflake is faster at selecting from this data. We already covered that up there, right? So without going into individual query profiles, query plans, etc., we can like read between the lines. We can't draw conclusions, but we can read between the lines and say that the writing is what took Snowflake so long here. It could be that Snowflake is writing it into an optimized format, and that's why it can read so fast and it takes longer to write. I don't know, but in
Yeah,
a
I think
lot,
that's a great hypothesis, right? Like
yeah,
Snowflake does use a proprietary format. And it's one of those questions of what's more important for your use case, right? Do you have to have this highly performant format that your queries will then run much quicker and your select queries will run much cheaper? Maybe
yeah.
that's more important. And again, just reiterates the need to think about your specific use case and kind of ignore what the benchmark said, which probably maybe has nothing to do with your use case. Maybe it is similar.
So this is another just interesting one, just to look at the numbers real quick. So 2.4 hours versus less than 1 hour. So that's interesting. And this is with that outlier query included, the 64 columns by 6 billion rows. Now let's exclude the outlier and just put your eyeballs right here where it says 4 hours, 5 hours. And then I'm going to turn this on, just put your eyeballs there. Now we're looking at 34 minutes when we just exclude that one query from both platforms. But the results are actually still the same. Where if we look at this medium, we're looking at 31 minutes versus 17 minutes. We're looking at 15 minutes versus 8 minutes, and we're looking at 8 minutes versus 5 minutes. So that's a
Yeah.
little diminishing on the larger warehouses, but
I did just remember, Jeff, important thing to call out for this is Snowflake now has 2 generations of their virtual warehouses. They have something called Gen 1 and they have something called Gen 2. Gen 2 is actually much more optimized for writing data. It uses specific hardware and software improvements for doing that. I believe either Jeff or someone else ran the benchmark using Gen 2 and the performance sped up drastically on Snowflake, but it did not materially change the results of the overall experiment in terms of the I think Databricks was still faster in the end and still
Yeah.
cheaper. But I just want to call that out for anyone on the Snowflake side listening to this. This was all Gen 1 warehouses. And you hear about Jeff making some comments around, hey, it may have been that the writing piece was what Databricks was actually faster on. Even changing to Gen 2 didn't, which is known to write faster, didn't change that
Yeah.
experiment.
So we've crowned Databricks the winner of this category number 4. So on to the final category before we wrap up here. Scenario 5, which is the delete plus insert. So after you build your big table once, you're normally going to insert incrementally. And if you need to merge data in, one popular way, instead of using a merge statement, is just to delete the matching primary keys and then reinsert them. It's an incredibly common ETL pattern that people do. The process here is start the clock, delete 1 month of data, which is about 1% of the data, reinsert the same month from the original source, and then destroy the warehouse and log the results. But we did need to copy benchmark data first, so we had something to reinsert from. Like we needed more or less 2 copies of the data at that point. So the copying of the data was not included in the wall clock time because it wouldn't make sense to. So scenario 5.
I'll pull this up. It's a great call out of we've talked about 2 predominant platforms, Snowflake, Databricks. Google BigQuery is actually something that's just not really talked about at all. Maybe because it's not a public standalone company. It's just part of the Google Cloud platform, but it is a massive, I would argue it may be one of the most adopted platforms silently out there because every Google Cloud customer pretty much uses BigQuery. And both Snowflake and Databricks actually have very low adoption on Google Cloud platform because the BigQuery offering is so good. So we'll make sure we cover that on the next one. I think it's a great call out. And it's like BigQuery is worth being in the mix. And I'm sure someday we'll also have Fabric in the mix as well, which has only been around for a few years from Microsoft, but is like rapidly gaining a lot of traction and a lot of investment from Microsoft.
Perfect. So in this delete plus insert, Snowflake just absolutely killed it. So this was deleting 1% of the data, which would have been about 60 million rows, I think, whatever 1% of 6 billion is. And at all of the levels, Snowflake just destroys. It's really interesting to see this really tight cluster of data right around here. Of course, the small is just, you would never use a small warehouse to process that much data. But actually, maybe you would because it's still less than 60 seconds. But that's the result.
We tried reducing the Snowflake warehouse. And yeah, so the answer is yes. I think on most of these, maybe not all of them, you do have the option to just compare extra small. If I'm interpreting this correctly, have you tried reducing the size?
Yeah.
I think you should be able to get this on most charts. It's like, did you compare extra small Snowflake versus small? And I think when we did that run on here, so we didn't do it on this because it would just take, I think for some of these experiments, it would just take too long.
It
But
takes longer. Yeah.
yeah, you can on the charts. You can later go look at the web app and do that comparison. But
Small was the smallest we went because on a 6 billion row data set, would you really use an extra small? Maybe some people would sometimes, but I think small is like the entry point for that data set. Cool. So I did just flip to $3 a credit right before Ian started talking. It doesn't really change the results at all as far as who wins. It changes the magnitude of the cost result.
I'll jump into this quickly. So thanks everyone for staying with us for so long, and hopefully this has been helpful. Let's talk about what we saw, right? So we set up a benchmark data set and a set of benchmark representative queries against just a handful of the same tables at the end of the day. And what we saw is Databricks. So when we say one, like was both faster and cheaper when it came to these very heavy CTAS queries. So create table as select, you're recreating a whole table from scratch every time the thing runs, it outperforms Snowflake. On the flip side, we saw again on the benchmark queries that for the other categories like select style queries, other DML workloads, we saw Snowflake outperform in terms of, well, I should call out Jeff. I think was this like across the board cost and performance, or were you mostly summarizing here just costs?
I mean, there was some mix as we went up into the $3 tier. There was some like certain scenarios where Databricks won, but for most of the other categories, I would crown Snowflake the winner.
I think the really important thing to call out here, which we iterated before, but worth reiterating, the results are highly dependent on what you input as your cost per credit or your cost per DBU, right? So depending on the plan you're on, the discount you get, that can have a huge impact. That can, in fact, completely flip the results, right? So hopefully from all of this, it's intentional that we're littering this with caveats because the world is not black and white. It's gray and muddy, and you have to apply judgment. You have to understand your specific use case. And that's why I want to just restate what we mentioned earlier. Benchmarks tell you about one thing, which is the benchmark and nothing else. So hopefully from this presentation, you've learned about the nuance that goes into evaluating a platform, about all the different factors that can drastically change a result, and therefore all the bias and potential misleading results you should be aware of. What can we draw in terms of conclusions? I think the only conclusion we can draw is just how nuanced and sub and variable these results can be. So the conclusion should be, if cost and performance are key things you are evaluating on these platforms, you have to just try them both. You have to test them on your workloads, and you have to apply the factors that are true to you. What is the plan you're on? What is the discount you're getting? What are the types of workloads you're running? What are the tables you're going to be using? You just have to apply your information. So I know that's not the flashy clickbait result you were looking for of Snowflake wins or Databricks wins. The answer is it's nuanced. It depends. That is life. And the only other thing you really have to remember, just to call out, is we evaluated like one specific feature of each platform, which is this data warehousing workloads. When you're choosing a platform, you need to look at other things like, what other types of workloads am I be running? What other features are important to me outside of just how quickly a query runs or how much a query costs? How easy are each of these platforms to use? Can I hand this to a operations person at my company and have them go self-serve numbers? That's incredibly important. Your time, remember, your time is often way more expensive than any of these queries are going to run. So what's the total cost of ownership? Those are all things you're going to need to consider when you're making a decision. But we hope this was a helpful piece that you can bring into your analysis if you ever are embarking on understanding these two platforms. They're both awesome. Honestly, you can't go wrong with either. One may be better for some people, one may be better for the other people. But yeah, with that, I think we'll wrap up. So thanks so much for listening. Happy querying, happy data analyzing, all those things. Jeff, thanks for all your hard work here and putting together this awesome set of benchmarks and results that we could stare at for an hour.
Absolutely. Thanks for letting me do this, Ian. It's been really fun, and we're right on time here. It's absolutely perfect. Couldn't be any more perfect. So see you next time.
All right. Bye, everyone. Thanks so much.